Welcome back to another lecture on biostatistics or statistics for the health professionals, PHA 205. In the logic of this course, the way this course is designed or it is set up, we started up with the general introduction of to why we need statistics, and then we define the fact that statistics is made of two arms, the estimation and the inferential. And we targeted the estimation statistics by first defining the different types of variables, and then we moved into talking about how do we estimate through the two arms of estimations, اللي هن summary statistics, summarizing data, and presenting data. However, at one point in time, we said that when you're working with statistics, you're actually working in samples, and samples produced estimates, and the nature of things is that there is the issue of probability that comes into play, and hence we have to visit the concept of probability so that we can use that concept of probability to move into estimation further with estimation and with inferential statistics. And therefore, this lecture actually introduces the basic definition of probability. So we start off saying that we're going to talk in this course about objective probability, the one that is rooted in math, also known as classical probability and relative frequency probability. We're not talking about the subjective probability. So the definition I'm going to give to probability is a very simple definition. I'm going to say that when you have um, an event that can have multiple outcomes, one of these outcomes or multiple of these outcomes could be considered success, and therefore the probability of this success to occur would be the number of the, the number of ways this success can occur divided by all possible outcomes. So for example, if you think about rolling a die, what is the probability of getting a 6? Most of you would know that the answer to that is 1 over 6. And the reason you said that is because you know that when you roll a die, you only one of the faces that has 6 on it, whereas the other faces they have 1 and 2 and 3 and 4 and 5, and hence you have 6 possibilities. Only one of them is 6, which we have defined to be the success, and therefore the probability of success or the probability of getting a 6 is 1 over 6. Similarly, if you think about a deck of card, for those that are not familiar with the deck of card, let me give a brief introduction of uh, what constitutes a deck of card. So briefly, a deck of cards is made out of 52 cards. These 52 cards are split into the hearts, the diamonds, and both of them are colored red usually, the spade, and the clubs. Okay, and in each deck of card, you have numbers going from 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. Also, and however, the number 1 is also called as ace. So 1 is also known as ace. And then at the end, you have the valet, you have the queen, and you have the king. So in total, you have 13 cards that are hearts, 13 cards that are diamonds, 13 that are spades, and 13 that are clubs. Okay. Also, in total, you have 4 aces, 4 twos, and etc. So you have 4 valets, you have 4 queens, you have 4 kings. Okay. However, you only have 1 king of heart. Okay, you have 1 queen of diamond. So that's a brief introduction of what constitutes a deck of cards. Let's go back to our lecture. So again, in a deck of card, if we ask what's the probability that you take one card and that card is a queen, well, if we apply the definition that we just identified, it's the number of success. So how many queens do we have in the deck of card? You have 4 queens. What's the total number of possible outcomes? And 52 cards, and therefore the probability of queen becomes 4 over 52. Also, we have something called the frequency probability, and basically that's where you're given something like this. This is called a contingency table. You've seen this when we talked about summarizing data. So the variable of interest is coronary vascular disease, and it's either present or absent. And the frequency in such that you have 150 individual with CVD present and 2,500 with CVD absent. Obviously, the total here is 2,650 because you need to add up both frequencies. And therefore, if you're asked what's the probability that you get at random one person from the sample, that person will have CVD and a CVD will be present, applying the same concept, you have to ask yourself, how many successes do I have? Well, I have 150. What are all the possible outcomes? It's the 2,500 plus 250 for a total of 2,650, and therefore the probability of CVD becomes 150 divided by 2,650. Okay, so let's continue with some more definitions. When you have two events that are uh, complement, we call them A and A bar. Complement events in the events that complement in each other to constitute all possible outcomes. So, like when you say flipping a coin, it's either a head, the complement of head is tail. Okay? If we go back to our example of tossing a dice, the complement of getting a 6 is everything other than the 6. So 1 with the 2, with the 3, with the 4, with the 5. هول مع بعضهم, they come together. They are the complement of 6. For the deck of card, if you want to consider what's the complement of queen, that's everything that is not a queen would be a complement. Okay? Now, in this example, I made it simple so that the complements in the A and A bar. Okay? But as you saw in my example, A bar could be a grouping of things together. They constitute A bar. So هيدي اسمها complement. Okay? So for example, if you think about gender, boy and girls or boy and girl are complement of one another. For a course, pass or fail, هني complement one another. Together, you have covered all the possibilities of the event. There's nothing left out. Okay? Not to be mixed up with mutually exclusive. Mutually exclusive are two different events. One event is A, the other event is B, and they do not share any common elements together. Okay? So boys and girls منن mutually exclusive, they are complements. Pass and fail بنسميهم complements, not mutually exclusive. Mutually exclusive is like female and prostate cancer. Okay, these belong to two different events. One event is gender, the other event is cancer, type prostate cancer. However, none of there's no common elements between the female and the prostate cancer. Another example is receiving financial aid and being the faculty. These are two mutually exclusive events. They share no elements between the two. Okay. Whereas if you have two events that do overlap, then the area where they overlap is called the intersection. These are the elements that belong to both A and B, and therefore we say A and B. Okay, so when we say A and B, we mean that both A and B are happening at the same time. Okay, so for example, female gender having cancer. في intercept أكيد في intercept. The intercept هن females and having um, cancer. You can think about gender and wearing eyeglasses. So being boys and wearing eyeglasses, that will include all the boys. No, that will include only the boys that are wearing eyeglasses. I would have boys not wearing eyeglasses. They're not part of my intersection. And I would have girls wearing eyeglasses. Come in, they will not be part of my intersection. Okay? So if I want to go back and think about it real quick, what I just mentioned. So let's say this is everybody that is wearing eyeglasses. Okay, so I'm just doing this so that we know that these are wearing eyeglasses. And this is everybody who is a boy. Okay, so what you have in between هن الboys that are wearing eyeglasses. Okay, so what you have here, these are the boys that do not wear eyeglasses, and what you have here, these are the girls that wear, yani those that wear eyeglasses that are not boys, and therefore these are the girls that are wearing eyeglasses. Okay, the area in between is what we call the intersection, and it's boys and wearing eyeglasses. Okay, so we continue with our definition. However, if you want to take all the A's and all the B's, so the success is A or B. So we talk about a union with a U like this, and we say it's A or B. So both. If you meet either of the condition, you are considered a success. And the example is university students holder of a BS degree. So the union and all the university students or holding BS degree. So it's both. It's not either. So if we go back to the example we were talking about, this time it's wearing eyeglasses, okay, or being a boy. Okay, so whether you, the minute you wear eyeglasses, you're a success. So it's all of those that wearing eyeglasses. However, we're also going to take all the boys. So again, we're going to take all the boys. So both are part of my success. Okay, all right. So in a nutshell, what are the properties of a probability? Simply, probability is always positive. ما في a probability that is negative. If you are running some calculation and you come across or your calculation yields a probability that is negative, make sure that you made a mistake and repeat your calculation. A probability could be equal to zero, and that's when the outcome is impossible to occur. So, for example, rolling a dice and getting 7, that is impossible, so you get a 0. Okay? Also, you can get a probability that is equal to 1, and that's where the success is definitely going to occur. So, what is the probability that you roll a dice and you're going to get a number between 1 and 6? Well, you're sure you're going to get a number between 1 and 6, and hence the probability is equal to 1. However, a probability cannot exceed 1. يعني again مثل ما قلنا probability cannot be negative, a probability cannot be greater than 1. ما في شيء اسمه 200% probability. Okay, that's subjective probability. Whereas in mathematical probability, a probability is bound between 0 and 1. 0 means impossible to occur, 1 meaning 100% it's gonna occur. And as the probability fluctuates between 0 and 1, as it gets closer to 1, it means that the outcome is likely to occur. And when the probability gets close to 0, it means that the probability is unlikely to occur. So, for example, winning the lottery should give you a probability that is close to 1 or close to 0. The answer, it should be close to 0, but it's because it's very rare. It's not 0 because people do win the lottery. However, it's very rare. Whereas saying what's the probability that during the winter a student is going to get the flu, that probability should be close to 0, close to 1. Well, since most of us do get the flu during the flu season, then that probability is probably going to be close to 1, like 0.8 or 0.9. Okay? When you have when you calculate probabilities, the sum of the complements will always add up to 1. Okay? So remember when we talked about the probability of queen, is that the probability of queen is 4 over 52, then the probability of not a queen, it's the complement of queen. Well, it has to be everything else than is a queen, and hence it would be 48 over 52. Okay? The probability of getting a 5 plus the probability of getting everything except the 5 add up to 1. The probability of an image, knowing that an image is the valet, the queen, and the king. So I have 12 images. That's the probability of an image, 12 over 52. The probability of a number, then it's everything else. And hence it's the 52 minus 12 divided by 52, so it's 40 over 52. These two together are complement. You add them up, you get 1. And this is helpful because sometimes you're asked to calculate a probability that is difficult to get. However, the complement, it's easy. And therefore, you get the complement, and doing 1 minus, you will be able to get your answer. Um, we may refer to probability as chance sometime, and that's when people think about something like that is desirable, like the chance of winning the lottery, if they're excited about it. So this is called a chance. It's still a probability. Sometimes we talk about probability as the risk. When you're thinking about an undesirable outcome, for example, when we're talking about a disease, we say the risk of cancer is this and that. So it's still a probability, but we call it a risk. And other times we call probability as a percentage, like 70% of the students are female, or 70% are male. That's a probability as well. Okay, so let's start doing some calculations, and let's see if we can apply what we learned. So here again you have a contingency table, but this is a two-way contingency table, and the reason it's two-way because you have two variables. One variable is smoking, with the outcome being none, yani non-smoker, ex-smoker, and current smoker. You can think about smoking as an ordinal variable. The other variable is gender with two possibilities, males and females, and you can think about it as a dichotomous variable or a binary variable, meaning a nominal variable. Okay, and the numbers are presented here. So the total number of sample is 600. That's everybody. 300 males, so all the males, they add up to 300, and all the females, they add up to 300. All the current smokers, they add up to 250. However, if you look at this 150, these are the males that are current smoker. So let's start with a simple probability. Given a table like this, if you're asked the probability of male, applying the definition, we said it's success over failure. What is a success? Male is a success in this particular instance. So how many males do I have? 300. What's the total? 600. And therefore the answer is 300 over 600. If I ask what a probability of current smoker, okay, so what's the success? كل الcurrent smoker, all of them, يعني the 250, and you divide by the total, which is 600. So that's the probability of current smoker. Okay, more examples. What is the probability of ex-smoker? So you look at the table and you notice that the total ex-smoker is 140, and therefore it's 140 over the total, which is 600. However, if I ask what's the probability of net ex-smoker, meaning the complement of ex-smoker, since you already calculated the probability of ex-smoker, then in that particular example, you can do knowing that these two will add up to 1, then you can do 1 minus the 140 over 600. Okay, that's a possibility. Another possibility, if you want to do it without using this technique, you can just look for everybody who's not an ex-smoker. So these are the ex-smoker, and therefore those that are not ex-smoker, these are the 210 and the 250. You add the 210 to the 250, you get 460, which is exactly what we get over here, and you divide by 600. That leads us to another type of probability, which is called a conditional probability. A conditional probability is not something complicated, it's very simple. All that means is that before you're going to calculate your probability, you're going to limit your space. what I mean the space is like your total, all the possible outcomes. You're going to limit that to the condition. So you have a limiting condition that is going to restrict your sample, and only after restricting your sample and looking at those that meet that condition, then you will calculate your probability. And you have to remember that when you restrict the sample, your total was restricted and the number of successes probably have been restricted as well. So that example is probability of current smoker given female. So the restriction or the condition is what comes after given. So given it's a female, it means that we know it's a female. So we're not going to consider those who are not female. So we're only going to look at females. Okay? So what that means, you're no longer looking at the entire table. You're going to only look at the females, which is evident in the next slide. Okay, so I'm highlighting the females. I'm only looking at the females as if the males do not exist anymore, which automatically mean the totals also do not exist anymore. So only looking at the females, you ask yourself, okay, among these females, who are the current smokers? And the answer, it's this 100. I do not take the 150 anymore because the 150 belong to the males. So I only look at the females, and part of the females I look at the success, which is 100, and now I divide by 300. My sample size was restricted by the condition. It was limited by the condition, okay? So I can write it as the probability of current smoker given female, or I can write it as the probability of current smoker. That slash right there, it means given, condition. Okay, so whatever comes after the slash is your condition. Okay, so these two are exactly the same. And actually, I'm going to show you more ways to write the condition. Okay, so here are more ways to write the condition. I can say probability of current among females. When I say among females, it means you're going to look at females only. Or I can say probability of current smoker knowing that it is a female. Or what's the probability of current for a female. So these different ways are exactly the same thing. فيني أقول given a female, slash female, among female, knowing female, for a female. That it's just different ways of saying the same thing, and these are conditional probabilities. So let's do an example. This time you are asked to calculate the probability of male, and the condition is non-smokers. So again, you're going to restrict your space, your sample, to the non-smoker. Always start with your condition. You start with the condition. The condition stipulates non-smoker, so you're only going to look at the non-smoker. Everything else, كأنه they do not exist anymore. So in your mind, this should occur. In your mind, you're only looking at the non-smokers. And now you answer the question. Now it becomes very easy. شو probability of male? Well, the success هني 100 divided by the total 210, and that is the answer to the question. So more questions. Probability of ex-smoker. The condition is male. So as I said, we always start with the condition. So you're only going to look at the males. Okay, so when you look at the males, it means that your total now is 300. You ignore the females and you ignore the females and you ignore the total. So let me see if I could do that. Okay, so only looking at the males. Now tell me, who are the ex-smokers? The 50, and you're going to divide that 50 by 300. So the answer is 50 over 300. Okay, so I got back the numbers for the second one. The second one, the condition is female. So I'm going to ignore the male. I'm going to act as if the males do not exist, which means also the totals are no longer existent. I'm only looking at the females. And now the questions, not none, yani the complement of none. Everybody who's not a none. Okay? So who are those that are not non-smokers? These are the ex-smokers or the current smokers, and therefore you're going to take both. So the success now is 190 divided by 300. Okay, now you could have done the none and did the 1 minus the none, you would get the same answer. يعني كان ممكن you do the 110 over 300, but that is not your answer. 1 minus that will give you the 190 over 300. Okay? So let's do now the third one. Let me try to put back the numbers. Now your condition is not current. Okay, the condition not current, and therefore I have to delete the current. Okay, the condition not current. معناتها the current are not acceptable. So I take out the current. Automatically I'm going to take off the total as well. And now I only have these numbers in front of me, and the probability is for male. So now out of this table, who are the males? These two cells are the males. So you're going to add them up, get 150, and you're going to divide by the total, which is 350, and that is the answer to that question. All right, last one. Last one, as I mentioned previously, we always start with the condition. So again, this time the condition is not none. Okay, so everybody who's not a non-smoker is accepted, and those who are non-smoker should be ignored. So I'm going to ignore the non-smoker and keep the not those who are smokers. Okay, see, this is I'm observing the condition. Now the probability says the success those who are not ex-smokers. Okay, so I forgot to take the total as well. I'm sorry. Okay, now out of these cells, who are those who are not ex-smokers? Those who are not ex-smokers are whatever is left, yani current. Okay, so it's these two cells. They add up to 250. Okay, so it's 150 and 100. You add them up, and then you have to divide them by the total, which is 390. Okay, these two cells together, or these four cells together are 390. Okay. More probability. Now we're going to look at the intersection, or what is called the joint probability. This is where we're going to use the reversed U, also known as the AND. So the joint probability for a person to be successful, considered part of the success, they have to meet both of the successes, okay, at the same time. So that person has to be a male and an ex-smoker, okay, a male and an ex-smoker. So the way to do it is you're going to look at who are the males, who are the ex-smokers, and where they intersect. That is your successes. So whole 50 are male and ex-smoker at the same time. So these are the success. Now, did I have a condition here? No, I did not have a condition, and therefore I'm going to divide by all the possibilities, which we're back to the 600, and therefore the answer is 50 over 600. More example, this time we're asking should a probability of current smoker and female. So those who are females and current smoker at the same time. So again, it's the intersect between females and current smoker. So it's that 100, and there's no condition. So I'm going to divide by 600, and that is my answer, 100 over 600. Okay. Not to be confused with the union, and which we'll do in a second, the or. And they have to meet both at the same time. So it's a female and current smoker at the same time. Okay, so let's look at examples. The first example says not ex-smoker and male. Okay, so these are the males, and those who are not ex-smoker are the non and the current, and therefore the intersection is happening in this cell and in that cell. Okay, so I have two cells of intersection now. I add up these two cells. These are my successes, 250. There's no condition, and therefore I divide by 600. Let's move to the second one. The second one has a condition. And remember, when we said you have a condition, you start with your condition. So first thing, I do not want, the condition is not a current. So I do not want the current smokers. Take them out. So we delete the current, and at the same time we delete the totals, not to make a mistake. And now I look at the probability. The probability says none and female. Yani those who are female and non-smoker. Those are the females. Those are the non-smoker. They intercept in this cell, which is 110. So the 110 are my successes, and you're going to divide them by the total. Which total? Whatever is left out by your condition, which is 350. So 110 over 350. The third one, I have a condition, but the intercept is in my condition. Okay? So I have to meet the condition first, and then I calculate the probability. However, the intersection is my condition. So it means I only want those who are male and not current smoker at the same time. Okay? So I only want males and not current smoker. So I want that intersection. So the females, I do not want them. So there's no females, there's no totals. And I'm not done because it's not the males that I want. I want the males and not current. So the males intercepting with the not current. So intercepting with none is okay. Intercepting with ex-smoker is okay. Intercepting with current is not okay. So I'm going to take this out and the total out. So in fact, this condition left me only with two cells. And now the question becomes, what's the probability of ex-smoker? Well, there's only 50 left that are ex-smoker, divided by the total, which is 150, and therefore my probability is 50 over 150. Okay, let's put back all the numbers and do the last one. The last one says, not ex-smoker and not male. The good news, I don't have a condition here, so I know I'm going to divide by 600. But how am I going to do this? Well, not male means females. So actually, I'm looking at this intersection of females with everything who is not an ex-smoker. So females intersecting with anything who is not an ex-smoker. So it is female intersecting with non-smoker and female intersecting with current smokers. So these two cells are my successes. So it's 210. And as I said, there's no condition, so I'm going to divide by the 600. Okay, so let's continue. That takes us now to the union probability. Union probability, as I said, that's where you're going to take both. So male or ex-smoker. So either you're a male or you are an ex-smoker. Both will be enough to be considered as a success. يعني part of the success حيفوتوا females. Yes. ليش فاتوا الفيميلز؟ لأنهم ex-smokers. The part of the success حيفوتوا مثلا current smokers. Yes. ليش فاتوا؟ Because they were male. Okay. So let's look at how we do it. So in the union, again, you're going to highlight the males, and you're going to highlight the ex-smoker, and you're going to take everybody that has been highlighted. Okay, so I'm going to take the 100, the 50, the 150, and the 90, and all of those are successes. So by adding them up, I get 390. There's no condition, so I'm going to divide by 600, and that would be a correct answer. Now, sometimes we are tempted to look at the total of males, 300, and the total of ex-smoker, 140, and saying 300 plus 140 and divide by 600. That is wrong. 300 plus 140 will give you 440, whereas we just realized it should have been 390. The reason, the mistake is that this 50 was counted once with the males and once with the ex-smoker. So you've counted the 50 twice, which is incorrect. So if you want to take the totals, taking the 300 plus the 40, you would have to extract or subtract 1 time the 50 because that 50 has been counted twice. Or if you use the simplest way, like just adding the cells like I did, then you won't do that mistake. Let's look at another example. This example says male or non-smoker. So again, you highlight the males, you highlight the non-smokers. So 100 plus 50 plus 150 plus 110, that will give you 410, and you divide by 600, you would be correct. If you wanted to take the totals, or what we call the marginals, so, and the 300 male and the 210 non, if I add the 300 to the 210, I have to make sure to do minus 100 because that 100 has been counted twice, once with the males and once with the non, and therefore I take it one time out. That, and then I divide by 600, that will give me the correct answer. So let's do weight exercises. The first one says not ex-smoker or female. So you know that you're going to take all the females. Okay, so let me see if I can find a nice way um, to put them. Okay, so I put them in blue. So all the females are in. And since it's or, so I'm going to add everybody who is not an ex-smoker. Not an ex-smoker, yani the none is going to come in and the current is going to come in. Okay, so basically all the cells that have been highlighted are part of my success. So I know that 110 plus 90 plus 100 is 300. I add the 100, I had the 150, that will give me 550. I divide by 600. Why? Because I do not have a condition. 550 divided by 600. Okay, sorry. Okay, now let's do this one. Well, this one has a condition. Okay, I'm sorry, I jumped the slide. I did one undo too much and that jumped the slide. We were here. Okay, so we finished this one. And now we're going to do that one. However, it has a condition. Like we said previously, first take care of your condition. So everything, the condition is male. So everything who's not a male, we're going to delete it. We're only left with the 300 males. Now let's do the probability. The probability says current smoker. So I take the current smoker. And it says or ex-smoker. So also I'm going to take the ex-smoker. So that's 150 plus 50, that's 200 divided by 300, exactly the answer I have. All right, the third one, come in and the condition. So I start with the condition, and the condition has the union. So the condition says take all the males or the not current. So who is going to be kicked out? Those that are female and current at the same time. Okay, so female or current, I'm going to have to delete them. All right, so once I do that, let me delete the totals so that I do not make a mistake. Okay, this is my condition, the males or not current. Now let's do the probability. The probability says not none. Okay, meaning not none. So I have the ex-smokers and the current smokers. So it's 150 plus 50, that's 200. 200 plus 90, that's 290, divided by everything I have, which is 500, and this is exactly what I got. Okay? The last one is, excuse me, the last one also has a condition, so let's start with the condition. The condition says take all the females or the not none. So anybody who is a male and none is out. So male none is out, and therefore I'm going to delete the total so that I do not make a calculation mistake. And now the probability is ex-smoker and male. It's an intersection, ex-smoker and male. Meaning an ex-smoker and male is just this 50. So it's 50 over everything else, and if you add up everything else, you're going to get 500, and that is exactly the answer, 50 over 500. All right, so I already mentioned that. I said that watch out when you're going to get the totals from outside, the 300 and the 210, for example. Watch out for the 100 that has been counted twice. So you have to take it one time out. And this is actually part of the additive rule, which we'll get in a second. An application of probability in research. This is a very nice example. Here you have, they looked at smokers and they looked at non-smokers. So they had 6,000 non-smokers, 4,000 smokers for a total of 10,000. And when they started looking at cancer, they found out that in total there were 300 cases of cancer, 25 of which are among the non-smoker and 275 are among the smokers, and therefore you can figure out the rest. So if you want to calculate the probability of cancer without any condition, that's everybody who's got cancer, yani 300, divided by everybody, which is 10,000, and this is 3%. If you want to calculate the probability of cancer condition smoker or the probability of cancer among smokers, then you have to limit yourself to your condition, which are the 4,000 smokers, and then you take the cancerous among the smokers, which is the 275, divided by the 4,000, you get a percentage which is 6.88. Same thing if you want to calculate the probability of cancer among the non-smoker this time. So you're only going to look at the 6,000. You have 25 cases, you divide by the 6,000, you get 0.4%. And what the researchers do, they say, well, look, the risk, remember we said that probability can be called risk. The risk of cancer for the non-smoker is 0.4. However, for smoker, it's 6.88%, and therefore there is an increase of 17 folds. This is an application of probability in research. The numbers I'm showing you here are hypothetical. All right, so everything I showed you can be done also using some rules. So there is a rule that is called the multiplicative rule. The multiplicative rule is used when you have an intersection, and hence the probability of A and B, A intersection B, is basically the probability of A times the probability of B with the condition that A occurred. You can flip it. You can say it's the probability of B times the probability of A with the condition that B occurred. And here I'm looking at the probability of male and non-smoker. So the probability of male is 300 over 600. And now I'm going to multiply it by the probability of non-smoker with the condition of male. So it's a probability of non-smoker condition male, and you can see that in this probability I'm dividing by 300 because it's a conditional probability, and I only have 100. So it's 100 over 300. So now to get the joint probability, a and non-smoker, a male and non-smoker, I get the probability of male, and I multiply it by the probability of non-smoker given male, and that will give you the 100 over 600, which we kind of like figured out on our own using the frequency table. Okay, so as I mentioned, condition probability, the joint probability or the multiplicative probability A times B, probability of A and B is the probability of A times the probability of B given A. Okay, and by switching things around, you can figure out that the probability of a conditional probability A given B is basically the joint probability of A and B divided by B. You always divide by the one that was presented as a condition. The additive rule, I talked about it multiple times. This is probability of A union B, A or B. It's basically probability of A plus the probability of B. However, you have to kick out the intersection because, as I've mentioned before, the intersection is part of probability of A and it is part of probability of B, and hence it has been counted twice, and therefore you need to kick it out. And I have the example, and you work out the example to get the exact same result. Two events are called independent. One mistake that is commonly done is that students think if A and B are independent معناتها they're mutually exclusive. لا ما مظبوط. A and B are independent even if they occur at the same time. However, look at this. If A and B are independent, then the probability of A conditioned on B is just equal to the probability of A. Yani the probability of A does not depend on the presence or absence of B. So, for example, is a coronary heart disease is independent of gender. It means that coronary heart disease, the probability of coronary heart disease is 10% either if you're a male or a female. It does not depend on the gender. So it's 10% in male and it's 10% in females. It does occur in male and it does occur in female, but the probability doesn't change. It's the same. Okay. So we say that coronary heart disease and gender are independent. Again, independent does not mean mutually exclusive. So if you have A and B are independent, therefore the probability of A and B becomes probability of A times the probability of B. لأنه مثل ما قلنا the condition A that is used to be here is خلاص, is disappears, is no longer, and therefore it's just A times B. And the union probability A or B is just the probability of A plus the probability of B minus the intercept. But since it's independent, the intercept, I can write it this way, and therefore I can write probability of A times probability of B. Mutually exclusive, as I said, it's a different story. When A and B are mutually exclusive, the probability of A or B is just A plus B. ما في intersection. The intersection is equal to 0. They do not intersect. Okay? The intersection is equal to 0, and therefore ما في minus anything. However, if A and B are mutually exclusive, then the probability of A given B while the probability of B given A becomes equals to 0. يعني prostate cancer and women are mutually exclusive. شو probability of prostate cancer condition she's a female, it's 0, does not exist. أو شو probability she's a female if prostate cancer exists كمان it will be equal to 0 لأنه they do not intersect. They are mutually exclusive. Okay, so here you have some applications. What is the probability of queen and the queen? So, and also we have what's the probability of only one queen and two cards, and what's the probability of two cards and none is a queen. I'm going to leave the application for a separate short video where I will go over the application, and we may address these as well during the WebEx meeting or the live sessions. So that concludes the introduction to probability.